So I'm going to leave over to Daniel North and Mike Withington with a warm hand and Sara Onrubia Garcia.
Perfect. Thanks for the introduction. Thanks for having us, and thanks to everyone for attending the call. Yeah, so we're just going to give a bit of an overview of Granta, really. So we're just this is the brief agenda. So we've just briefly done the introduction. So myself, Micah, and Sarah are all part of the Granta team. We're actually based out of the UK. In Cambridge, and we support PDS Vision with anything to do with Granta, really. So we're just going to do a bit of an introduction, and then I'll give a brief overview of the Granta portfolio, a little bit about what we can offer, and then we're going to really focus on Granta Selector, and this is a tool for making smarter material choices. Mike is then going to give us a demonstration of Selector, so you get to see it in action. So he's going to go through a case study. So this is a real life case study. It may not be completely applicable to everyone on the call. However, it should give you a good indication of what the tool can do, and how you can transfer those over to the products you're currently working on. And then at the end, we'll have a short wrap up and a Q&A. So like Roger said, if you do have any questions, please pop them in the questions tab on the right, and we'll try and get all of them answered by the end of the session. Any which we can't get answered, we'll take away and reply to you after the webinar. So the value of materials information. So why does materials information matter? So I'm sure everyone on this call understands that materials plays a very major has a major impact on products and everything you're working with at the moment. So materials information really can be leveraged for a number of reasons, and I've just listed a couple on the screen here. So it can really support growth. So we have a lot of companies who lightweight with composites, or innovate through additive manufacturing. We have more and more companies as well looking at the environmental impact of their products, and in turn their materials as well. But not only does it support growth, as most companies will want, it can help them increase profit and reduce costs as well. And this is by understanding the material's behavior, you can actually increase the product lifetime. As well as this, you can ensure you get the best return of investment from simulation by ensuring you have the right input data. So making sure you have the right materials information going into simulation will really get the best results as well. And you also lower the cost which is spending on materials by substituting for the optimal material, and this is something we're going to look at later today as well. We've actually had a one customer who's done this quite effectively. So they actually substituted, they were using a certain material, they substituted that material with another one, which had similar properties, but it was just at a lower cost. And they actually saved around 2 million euros just by swapping that single material out. So it can have quite a big impact. And then also, as well as this, it helps remove risk. So there's a lot of legislation out there about what substances you can have within certain materials, and by ensuring you have the right materials information, you can minimize regulatory risk. You can reduce warranty issues or recalls, and then in the medical industry, we have a lot of companies in the medical industry, and they use it to avoid risk to human health by understanding exactly what substances and materials are there. They know how it works with the human body. So we understand materials is not just for the material expert or the product designers or even simulation. Materials information needs to be used by a huge variety of different people within the organization. And it's really important that every one of these teams and areas gets the right information, and it's important that everyone's using the same materials information. Um, and this is exactly where the Granta portfolio can help with. So, so when we look at the Granta portfolio, there are four main product lines, or three. Obviously, MI Pro and MI Enterprise comes into one. So like I said, today we're going to be focusing on Granta Selector, but I'll just give you a quick overview of the others just to make you aware of them. And then if there's something of interest, we can have a further conversation and we can give you more information about it. So the first one on the left-hand side is material data for simulation. So this is actually linked with the Ansys flagship product or products. So this is a list of around 2,000 material cards. And this is embedded within Ansys Mechanical, Electronics, Desktop, Fluent, and Discovery. So what this is as you're using any of those products, when you click on materials, if you have this installed, you will have a list of 2,000 different materials with about 10 to 15 properties on each one to help those simulation engineers. We'll then go into Granta Selector. And Granta Selector is a standalone tool. So even though it does link to other tools, you can just download it onto a laptop or computer, and away you go. And Granta Selector is a tool with a lot of reference data. So it has hundreds of thousands of different material data sheets. And the real benefit of Selector is enabling companies to select the optimal material for their application. So it does this with a lot of reporting tools. So you can compare different materials side by side. And like I said, we'll go into this. This is going to be the main focus of the webinar today. When we then look into Granta MI, this is more of an enterprise solution. And the idea of Granta MI is to have a single source of truth. So everyone working off the same hymn sheet. So what Granta MI is companies use this to store all of their in-house materials data. So by having this single source of truth, everyone within the organization can use, it is working off the same system. The main difference between Granta MI Pro and MI Enterprise is really the complexity of the data that it can store. So with MI, you can link it with your CAD or CAE or PLM systems as well. And with MI Enterprise, you can also link it with, if you're doing any materials testing or if you're working with additive manufacturing, you can link all those machines with MI to be able to capture all that data, store it, and analyze it as well. But like I said, we're going to focus on Granta Selector today. Okay, I'll just skip another slide. Okay, so the optimization of products. So to get an optimal product, you need obviously two main elements. You need the optimal design, but you also need the optimal material. It's okay having a very good design and even going through simulation and things like that is very important. But if you don't have the right material, you're still not going to be able to get the right product at the end. So when it comes to selecting a material, everyone selects a material for usually one of the following reasons. So this could be you may have a product failure, or you want to improve the performance of a material. You may have a dual sourcing or supply disruption. So we've had companies in the past where the suppliers come to them and said, we're no longer making a certain material, and then they need to go and find an alternative supplier. So how do they go about doing that? We have companies obviously developing new products. There could be some in-house initiatives. So, every company wants to reduce the cost which they're spending on a material, or they may be looking at the environmental impact of the material, and they want to reduce the CO2 footprint or something like that. Could be a new material development, or simply it could be a materials related question. So this could be companies maybe using a certain material, and they want to quickly and easily understand what would happen if they used an alternative material instead. What would be the differences in those materials, and what would be the impact? And with the so when looking at all this, the main question here, as you can see, is which material should I be using? So it's usually, the materials expert or the product design and development team, engineering or simulation. But either way, it's always a question: which material should I be using? And this is the standard approach we hear from companies. So they'll have one of these material issues. They'll go to the in-house expert, and the in-house expert will do one of a number of things. They'll either use a material they've always used in the past, because that they know it and that they understand it, or they'll go to consultants, search the web, or speak to suppliers. And there's quite a lot of limitations to all of these ways of working, really. So when you go to suppliers, I'm not sure if many people on the call have done this, but you call them up and you spend a lot of time on the phone explaining everything about the product, all the details, materials, information, and all that stuff. And then the suppliers will it tends to be very difficult to get price for a start, but then also they're going to recommend the materials which they produce and they supply themselves. When you search the web, there's a lot of inconsistent data out there, so it's difficult to find exactly what you're looking for. And then consultants can be quite expensive, and at the same time, they'll usually do one of the first couple stages, or use something they've used before. So this is the challenges we hear from materials expert, design, even up to sort of the director level. So where can I find reliable materials data? There's thousands and thousands of materials out there, and it seems to be growing on a daily basis. So which ones should I be considering? We've also heard that once the material expert has found a material, they actually spend a lot of time convincing their stakeholders that their recommendations are actually the best one. From a design and development point of view, they want to reduce the number of design, test, and prototype iterations. And then, obviously, from a director level, we hear that they want to reduce product delays, cost, and failures. And this is where Granta Selector helps with these questions, really. So with Granta Selector, there's two main elements. So it's got this encyclopedia of materials data. So it's got thousands and thousands of different material cards, and materials information in there. But really, the real benefit of Granta Selector is the sort of the powerful visualization, filtering, solving, and estimation tools. So it's got all these tools embedded within Selector to help companies compare these materials next to each other. You can add limits to exactly, so you can exactly narrow down precisely what you're looking for. There's also supplier specific data on there. So once you've narrowed down your search, you can also find a supplier in a certain region as well. Once once you've done your selection reports, you can actually then export that data to CAD or CAE packages. So obviously we are part of Ansys, but like I mentioned before, this is a standalone tool, and you can export that materials information to. It's a bit small here, so I apologize for that, but to most CAD and CAE packages. So there's Abacus, SolidWorks, NX on there as well. And the core benefits of Selector is, you can innovate through materials. You can very quickly resolve material issues, and I suppose this is one of the key benefits here. Is Granta Selector is it does save a lot of time. We've had customers before who have tried to do a selection project, and it's actually taken them a couple of months. They then asked us to come in to see if we can do the same selection project in Selector to sell the benefits. And the same selection project actually took 30 minutes using Granta Selector. So there's a huge time saving by doing this. You can confirm and validate your choice of materials with a reporting tool. Once you've done your selection project, you can print a report, and you can also reduce cost of materials and R&D. So like I mentioned before, Granta Selector has two main elements to it. So this is just looking at the materials within the database. So it has this core material data, and this includes, you see in the top left-hand side, this is the material universe database, and this is unique to Granta. So the idea of this database is to incorporate almost every generic grade of engineering data, and it does this by putting it into a range. So all these properties are arranged to give you the ability to narrow down your search. This will then link to specific data sets. So as you can see here, we have advanced metals, polymers, etc. So depending on what field you're working on, you can have these specific data add-ons. So once you've done your initial search within Material Universe, you can then link to specific supplier grades of those materials and see the supplier data sheets as well with these advanced data add-ons. And then, like I said, I've mentioned about the reporting tools. So there's lots of different reporting tools in here. We won't have time to show everything today. So a couple of the ones we won't have time to show today. So the synthesizer tool, where you can actually do a part cost estimation. So you can estimate how much a part would cost. You can also do look at the eco audit tool. So like I mentioned before, this looks at the CO2 footprint of a material, and you can put in the sort of transportation cost, sorry, the transport, how material is going to be transported, and it takes all that into account. Also the end of life as well to give you a sort of CO2 footprint there. We've also got a battery designer tool. Like I mentioned before, you can do a selection report at the end, and also you can export material cards to specific CAD and CAE packages as and where you need to. Okay, great. So with that, I've already sort of gone over most of that anyway. So with that, I'll pass over to Mike, who's going to show you the selector tool and how it works. And like I mentioned before, he's going to do this using a case study. But really, the point of this is just to show you the tool, how you can do a selection study, and I hope you find it useful and see the benefits of how you could use it in your industry.
Good morning. Yes, as Daniel says, I'm going to walk you through a case study, primarily as a way to show you the features of Granta Selector. So the case study we're going to go through is a real life example from a customer that manufactured electrical connectors, and their requirement was that they currently manufacture this connector, and they're quite happy with the way it performs across a range of criteria. But as is often the case, there was a requirement to reduce the cost. So what they want to do is maintain the performance of the component, but try and see if there's a material that can meet the specifications and but also is cheaper. So what the first step is to do is to look at your current material and to identify the important constraints. So a lot of the properties of the material, there's no point in just comparing all the properties of the material. You have to identify the important ones that have an impact on the product. So what they did was work through and across a range of categories, they identified the important constraints. So in terms of thermal constraints, they had to have similar or better operating temperatures to their existing material, which was a material called PEI. They wanted to be able to manufacture it using injection molding processes, so it had to have good properties to enable that. Importantly, for an electrical connector, it had to have certain electrical properties, and a very important one was it had to have a similar or lower dielectric constant value, and also a value for CTI, which is a constant tracking index, and that had to be in a similar range to the existing material. But also there was a few other constraints, so it had to comply with various standards. So ROHS is an EU standard for product risk on electrical components, i.e. under ensuring that there's no substances of concern in the product, and also the REACH list and the SIN list. And then there are a couple of more constraints to do with the durability of the material. So it had to be resistant to fresh water, salt water, and solvents, as well as being have low flammability. And that all said, the objective was to see if it was possible to find a material with a lower cost, but all these different properties. So what I'm going to do is I've launched Granta Selector here. So we're on the home page of Granta Selector. And on the panel here, we can see a collection of databases. So as Daniel said, there's a whole range of databases, but the basic core is this material universe database, which has links to all the other databases. Then we have another database here, the JARM curve data. So this again is generic data, but it is curve data, so functional data, and that enables it to be used in simulation tools more easily. And then over here we've got a collection of other databases. I'm just going to click on the Senvol database. So we've got two categories of the Senvol database. I'm going to click on the materials. And you can see on the left we've got a tree structure of different materials. Over here we can click on information about the database, and we can see that the database is intended for managing or storing data to do with additive manufacturing materials or even machines. I'm going to return back to the materials section of the material universe database. So over here on the left, we can pick a subset of those and just say we're going to concentrate on polymers. We can see that the materials are organized in a logical tree structure. So our start point for our exercise would be to identify our current material. So I could browse down here and try and look for PEI, and eventually I would find it. Alternatively, I can search for it. And we get several hits. So I'm going to look at one of the ones in the Material Universe database, and I'm going to pick PEI unfilled. So as I click on it, the data sheet is displayed over here on the right. So this contains all the properties that are stored for this for each material, and they're grouped in different sections. So at the top we've got general information. So this includes its designation and various trade names that it's sold under across the world. And we can scroll down, so there's some chemical information of the compositional summary. There's the price information. So this is aggregated across the world every 6 months across a range of suppliers. And then we can scroll down to the important physical properties and mechanical properties. You can see all the commonly used mechanical properties, thermal properties, electrical properties. And then down here we've got our restricted substance indicators, durability. So you can see that there's a whole range of different categories of properties. So it can be used in all sorts of different applications and methods of selection. And at the bottom, we can see we've got environmental information, so we can make calculations based on the carbon footprint, the amount of water that's used in initial production, how much energy is returned on recycling, how recyclable the material is. And then at the bottom, we've got these links to these other databases that we mentioned. So for instance, there's one to the Global Polymers Plastics, and this allows us to have links to suppliers who can supply different grades of this material. So we could look in there and look for different grades of this material and then identify a global supplier. Okay. So I've found this material here, but I don't know where this is in the tree. So I can right click it, locate it in the tree, and the tree structure expands to the point where I can find this particular material. Next thing I want to do is just mark this out as a reference. So as I click this to make it a reference, a drawing pin is stuck in the material. So what this means for us is that we can now use this as our baseline material for comparing to other materials that we might identify as being suitable candidates. So I'm going to walk through like a filtering stage to try and identify a suitable candidate. But what we could do is just do a quick search across the database to look for materials that have similar properties. So up here we've got to find similar. And this goes and compares all the attributes that it's got stored with other materials in the database. And just compares them for nearness. So the closest neighbor is this PI material, and that has a nearness of, or an indicator nearness of 88%. So it's quite similar, but we don't know which attributes are near and which ones are far. So it's a similar material, but it might differ in some key attributes. So what I'm going to do is just pick a few of these at random, and we're going to do a comparison of a couple of likely candidates that we might use as a quick hit. So I'm doing a comparison, and we get a comparison table. So across the top we've got our materials. So this was our original reference material, the one we're currently using, and here are three quick guesses at what might be suitable. And down the left we've got a list of all the different material properties, all grouped by their category. And what we can do here is compare the values by their actual values or by a change, a percentage change, and we can highlight the significant differences. We can control this. So at the moment we're looking at if something is more than a 10% change, that property will be highlighted in orange to bring it out for us to notice more easily. So our closest material was this PI unfilled. So on the face of it, that might be quite a good candidate. But one of our most important criteria was our dielectric constant, one of these electrical properties. So we can just do a quick check, and we need a lower value or an equal value. I'm just going to scroll down to electrical properties, look at the dielectric constant, and immediately we can see that we can rule out this. Material because the dielectric constant has a higher value, which isn't any good to us. But we can go across to the next column and see that the next material has a value that's 20% or 19% lower. So we got this material COC. And we could now think, well, maybe this is a good material. And what we might do if we were doing a less rigorous process is now start going through a process of trying to justify to ourselves why this material might be used, and then go on a process of finding out all the different attributes, comparing them, and focusing in on this material. Okay, but we're not going to do that. What I'm going to do is go through the selector methodology now to apply filters to a range of materials to try and home in on the particular material that we do want. So I'm going to create a selection project, and what this has done is created us a list of all the materials in the database, and I'm just going to say, well, we're going to home in to begin with on the polymers. So we can see here that we've got 922 materials that might be of interest to us. Sorry, 921. Okay. So the first process I'm going to do is try and work out, can the product be manufactured with this material in a suitable way? So we've identified that injection molding is the way that we're going to work. And what we can do is filter out all the materials that don't have a link to this particular process. So we have another table of manufacturing processes, and we can filter out anything that isn't linked in this way. So I clicked on the tree stage, launched the tree stage. We're going to look at the process universe. And here we've got a list of manufacturing processes. I'm going to pick a shaping process, navigate down to molding, injection molding, standard injection molding for thermoplastics. And this identifies a process. So when I apply that process, it's now going to filter out from our 921 suitable materials, we're down to 619 materials that can be manufactured using this particular process. Okay, so the next stage would be, we want to find only the materials that have a suitable electrical performance criteria. So we mentioned before we've got two attributes that we're interested in here, the dielectric constant and CTI. So I'm going to create a limit stage now. You can see that we're building up a list of stages here, and this is kind of the story of our selection process. So we're on stage 2 now. I'm going to look for the electrical properties and our dielectric constant here. So because we've pinned the reference material, our original material, PEI, it's displaying here the range of values that we currently have. So what I'm going to do is say that our value has to be no more than the maximum value. So we're going to have to find only the materials with this electrical property. So again, I'm going to apply that stage, and our suitable material candidate list has now dropped down to 274 matches. So we're starting to reduce the number of records that are suitable. At this point, we might want to visualize a property of the selected materials. So what I'm going to do is create a chart at this stage, and so I'm going to and what I'm going to do is plot our dielectric constant, which was an electrical property, on the y-axis against the cost. So I'm going to find the cost. price per unit volume, and just generate a chart with these. So instantly we've got a bubble chart of all the materials that we're looking at so far. So you can see the coloured ones are the ones that are included in the selection criteria, and the grey ones are ones that have been excluded using our criteria. There's a few things we can do. First thing we might want to do is identify our reference material in here. So we can click on the drawing pin and identify our reference material. And if I just drag and drop that, we can label it quite easily to identify it. We can visualize the different families of materials. So we have an icon here to show family envelopes. So each of these envelopes shows a particular category of materials. Pick a couple of these. And we can completely hide materials that are failing our selection criteria as well at this point. Okay. So we're going to move on now with another selection stage. We're going to filter out based on our restricted substances, i.e. whether the material will comply to various standards like the ROHS and the REACH standards. And again, because that's a property of the materials, I can do this with another limit stage. And we can look at our restricted substance categories. And we can decide that, well, yes, we do currently we're compliant with ROHS, and we need that to be the case as well. And we'll enter similar values for the REACH and the SIN list. So I can put in 0, 0, and I'll put in 0.1 because that is a threshold of these legislations for 0. Okay, and then I'm going to look at the durability properties. And what we're going to say is it has to be tolerant to fresh water in the same way that our current material is. So we can see our current material is excellent resistance. Same with water. We've got organic solvents as well, need to be excellent. And then we want to make sure that the flammability is at least as good. So currently it's self-extinguishing, but also non-flammable is better than self-extinguishing. So we've added a few more criteria there. I'm going to go, and now you can see that we've homed in on 37 records of 921. So at this point, we're displaying just the records that have passed all these 4 stages at the moment. But as you might remember, at the beginning, we'd identified that there's a material called COC, which was a good contender. On the face of it, it looked like a reasonable match. But looking down here, we're sorting, we can sort alphabetically and see that there is no COC material in there. So it's quite interesting to now know why that isn't there. What we can do is look at a pass-fail table of all the different materials. And we can look down for COC, and we can see that it did indeed pass the first 3 stages of our process, but failed the final stage, this 4th stage. So we know that that material was ruled out on the basis of product risk, i.e. it contained a substance of concern, or possibly on one of the durability criteria. Okay. So had we broken that down into separate stages, we would have known exactly why it failed, but we've got an idea of what ruled that out. So that's quite interesting, because at the beginning we might have had we might have convinced ourselves that was a good material, tried to justify it by then devoting time to finding the attributes of it, and then at the last stage we might fail, and and then have to start again and look for another material. But because we've gone through a step-by-step filtering process, that's been done for us. Okay, I'm going to go back to our list of pastel stages. And we're going to apply a couple more steps. So at the beginning we said our first step was that it had to be manufactured by a polymer injection molding process, but we haven't quantified that. We've just said it has to be possible. But we have also attributes to say how good the material is at various processes. So I'm going to apply another limit stage on the processing properties. And we want polymer injection molding. And I'm going to select that it has to be acceptable or excellent again. Okay. We'll apply that. Okay, and now we're down to a smaller range of materials. So I can now go back to our chart. So our chart was saved, and we can see these particular materials that we've got. What I'm going to do is pick a particular material. Let's pick LCP. And we can label a few of these materials. Okay. And if I pick a few of these materials now, what we can do is go back to our comparison chart. And at this stage, we can look through and see which of these materials are suitable. So we know that these are meeting the criteria that we want. But what we can do is look through at the costs. And we can see that some of them are more expensive. But there's a couple of them here, the LCPs. One of them is 9% cheaper, one's 29% cheaper, and one's 14% cheaper. So these are starting to look like reasonable candidates because they meet all the criteria and yet they're cheaper. So I'm going to pick one of them in particular, and we can take a better look at it. Data sheet. And at this point, then we can start analysing and going through with a greater detail and just and check all the different properties. We can scroll down to the bottom because again we might want to identify a particular manufacturer. So we can browse through different manufacturers. I can find one here in Singer GmbH. And we can look at the data for a particular grade that this particular manufacturer makes. And when we look down at the key features of it, we can see that it's used in the automotive industry and it's used in electrical engineering. So these are good indicators because these are similar industries to the ones that we're trying to apply it to, and we can tell that we're not pioneers, and that it has been used for this kind of application in the past. Okay. And then from here as well, another thing I can do is, if we've decided we want to use this material, I can export this data card. Sorry, I've got to go back to the actual material. I go back to here. To the data sheet. From here, I can export the material to a range of different products, so various simulation tools and CAD systems. So I'm going to export to Creo Parametric, and we can export that to a file, and this will get saved to an MTL file. And an MTL file, it happens, is the file format that Creo recognizes. So here I have some Creo geometry, and we have the materials node within the tree, I can read in a particular material. So in this case, we'll see P, and we bring in the properties that were stored within selector, and they're accessible now, and we can use those in Creo. Minimize that. So finally, what we've shown is we've gone through a lot of working. We've built our stages up in our selection project. We might want to save this, in the same way that you would save your CAD drawings and things. So we save the project, and we can save that and open it tomorrow, and it'll be in exactly the same stage as we're at now. Alternatively, we might want to give our selection as a documentary evidence to someone that doesn't have selector, and what we can do is generate a selection report, and this generates a report that we can save to PDF or various other formats. I'll step through, and it details all the selection processes that we've been through, the diagrams that we've created, and the materials that we've selected, and also our final comparison chart. And we can use this as our evidence that we've gone through a rigorous process to select a particular material. Okay, so just returning back to the presentation. What we can see is we've been through a selection procedure. We've applied the important constraints so that we know that we're not compromising our product. It meets all the design criteria that we had before, but we've identified a range, so 3 or 4 different materials which meet the criteria and are cheaper. So we pass that on. Okay, so at that point I'll hand back over to Daniel.
Great, thanks for that, Mike, going through the demonstration there. Oh, let me turn my camera on as well, so everyone can see me. Yeah, so thanks for going through that. I think it was quite useful for everyone to see how Selector can work. Just a quick reminder, I think we've had a couple of questions already, but if you do have any questions, please put them in the chat on the right, and we'll go through them in a minute. So just wanted to finish just with a couple of case studies here. So these couple more of our recent case studies, and there is a link at the bottom here. So if you go on to the website, you can see case studies for pretty much any industry which we currently work with. So feel free to go onto that. So Aaron at the bottom actually use Selector to look at the environmental impact. Radial, was really saying the massive cost saving, the time saving. Like I mentioned before, we have quite a few case studies on how Selector really can save so much time, and it's really good product for early stage design. So when you're trying to really narrow down a few candidates for your application, Selector is a really good way of quickly being able to do this. I think obviously Mike managed to go through this case study in 25 minutes or so, to really narrow down the hundreds of different materials which could potentially be used, how you can save time by not initially focusing on the wrong material, like the COC. If you spend a lot of time trying to justify that, and then by the end you found out that it wasn't applicable. So I think that was a really good overview. So thanks for that, Mike. If you just pop to the next slide. So yeah, that's sort of coming to the end. Like I said, we'll go through a couple of questions. I think Roger can ask them. But I just wanted to finish that. If you do want any more information on any of the Granta products, like I said, we did focus on Granta Selector today. But if you want to manage your own materials data, then Granta MI is a good solution, and we're happy to give some more information on that. So if you do have any questions or you want more information, please contact Johan here. His email address is here. So we'll keep this up while we're going through the questions. And that's sort of concluded from our end. So I'll pass over to Roger.
Thank you very much for the presentation. And we do have a number of questions in here. And one that came in that we have a large material library, which is the standard incorrect library included in the Creo package. Could I get a large number of MTL files exported to the material library folder corresponding to the materials that I already have?
Okay, so you could identify each of those individual materials and export them from Selector. So roughly how many materials are you talking about as a large number?
Yeah, that is another question, of course, but a large material library.
Yeah, so you've seen the process at the moment. The idea is to not necessarily provide a material library in Creo, but to allow you to select materials and then use them in Creo. But yeah, it's feasibly possible to manually extract.
200 materials is a clarification here.
Yeah. I mean,
so that's feasible, right?
Yeah.
Okay, perfect. Can we show restricted substances in referenced and suggested materials?
The restricted substances that we've got in Selector are indicators as to whether that material is compliant or not. So they're legislation indicators and not complete links to the chemistry of the material. So we can address that in another of our products in MI Enterprise with the restricted substances modules, and that would give you a complete list of all the restricted substances that are contained in particular materials.
One question there is, how can I explore and know if a specific material of interest exists or not in a Granta product?
How a specific material exists in a... So you're basically looking to see a where used of a particular material. Is that the question? So basically we're generating an NTL file that would then get used in Creo, and that material will get applied in Creo, and you would have to have something in Creo to go and look at all the individual parts to identify what materials have been applied. Again, we have other packages, other systems. So MI Enterprise allows us to store all the different materials, and using the gateways that we have gateways for Windchill and gateway for Creo, we can apply materials to parts, and especially with the Windchill gateway, that will create an object in the Windchill database that relates to a Granta material, and because it's in Windchill and we get links between the part and the material, you can do where used searches from within Windchill, but that's not it's not an easy thing to do with Creo on its own.
Okay. So there is a question on how often do you update the price information?
Okay, so the prices are updated every 6 months with each release, and we've got a whole team of data products engineers who revisit the data and various packages of software to find indicative prices and come up with average prices for the generic grades. So that's every 6 months or so with each release.
Perfect. There are a couple of more questions in here, so we'll make sure that we will answer them in writing and send it out to all the participants. I'd like to stop with the question of what about price for this product, and just point out that this is the excellent opportunity to get in contact with Johan Adelgaard at PDS Vision to continue the discussion. So with that, and respecting to time, I'd like to thank you all, and thank the Ansys team for taking the time as well, and thank you all for attending, and we'll be close by with another webinar of interest soon. Thank you very much.